Hello everybody. Last time when we spoke about energy, I showed you this funny roller coaster, solar roller coaster. In this coaster we have solar cell and an engine and a lamp. We could use sun, but it works always in the same way. The energy of light is converted into the energy of the current, electric current. This current makes moving the engine here. The engine here moves the stairs. The stairs rise up the balls, give them potential energy, and they go down with the kinetic energy. Well, pretty complex. But what we want to learn from here is that to move a car, we could use sunlight. We could use the energy of light. Well, I have some cars here which could go with light. Let's try. Lamp and the solar cell and engine, and it goes. Start again, and it goes. Start again. It goes. Obviously, this is not very funny because we should go with the lamp behind the car. Let's try with this bigger one. The bigger one. Well, it goes, but it needs light. So, as long as we have light, as long as we have sun, it goes. But when sun is covered by clouds, then the car stops. What could we do? Well, we need to accumulate in some way the energy of light. How could we accumulate? We could accumulate in something which is called battery. Well, we already learned that this small car was going with the battery. We have a battery inside. I switch on and it goes. It uses the energy coming from the battery. It uses the electric energy coming from the battery. But how the battery works? Well, it works in a very simple way. This is a very simple experiment. I have just some salty water here and two pieces of metal, copper and iron. Then I connected here voltmeter, which shows 0. When I connect two metals together, it still shows 0. But when I insert these two metals into this salty water brine, well, it starts showing something. It shows electric current. I have created electric current. How much? Let's have a look. 0.2. I have created electric current just with two pieces of metal and salty water. Well, this is like all batteries work. All batteries work exactly in the same way. Two different pieces of metal and some liquid in between them. Well, this battery is called Volta battery because it was invented 200 years ago by Volta, Alessandro Volta, Italian teacher, and from that time we don't have anything better. We use Volta batteries everywhere, in computers, in tablets, in iPhones. Well, we use them everywhere. Well, to say the truth, the first battery of Volta was different. Sometimes we call the battery a pile. Why we call it a pile? Because the first battery of Volta was just a pile. A pile of different monnets, of different coins. Well, he used silver coins and tin coins. I don't have silver coins. I have these copper and iron coins. Well, what we should do? He put an iron coin. Well, I put a piece of aluminum just to have a better electric contact. Then I put a copper coin. Then I need to put some water. I put some piece of cloth in salty water, then another piece of iron, another piece of copper, and another piece of cloth, humid cloth, and now we need iron. I don't have another piece of copper. I will use this coin. Now we can check if I manage to create some electric current. I connect the lower part, the upper part, and we can check if this equipment makes some current. Yes, it makes some electric current. I created a battery. Well, a battery, all batteries are always done in the same way. Different pieces of metal which are connected with some liquid in between. Well, I have here, so it could work forever. Yes, it could work forever. No, it cannot work forever, because we cannot produce the energy from nothing. We produce this electric energy from, I should say, chemical energy. What does it mean? It means that after some time, the battery is exhausted. The battery is consumed. I have some consumed batteries here. You see that they are corroded. There is some liquid going outside, and the metal is used. The metal is corroded. It doesn't work anymore. What happened? We converted the chemical energy of two metals into the electrical energy, and the metals are consumed. I have two funny things here which worked some time ago. This is a small battery inside, a piece of zinc and a piece of carbon, and humid piece of cloth in between. Well, when I bought it 2 years ago, inserting this equipment inside, this car was going around. Now it doesn't go anymore because the metal is consumed. The same with this. Here again we have zinc and we have carbon, and again it is consumed. It does not go anymore. So water battery is a great invention, but it is getting consumed. Well, we could have a battery which can be recharged. We have many types of batteries which can be recharged, like a battery inside my phone, well, like the battery inside the computer. We can recharge them, but always in the same way because they use two different metals. Well, recharging my phone, I'm using always a supplier. Outside, I use the electricity from the net. I could use also the electricity from a photovoltaic cell. This is a charger that allows me to charge my phone with the photovoltaic cell. So, well, we almost got an idea how to make the car going with sun. We just charge the battery. Yes, we charge the battery. The question is what kind of battery? Because the battery inside my phone is lithium battery. It's very light metal, but it's rather expensive. We could use a cheaper metal, which is lead, but lead is very heavy. So what could we use? Well, then metals consume in some way. So, well, there's an idea which is almost 100 years old and which allows us to use not two metals but two gases. Not zinc and copper, not iron and copper, but use two gases. Which gases? Well, these gases which we find in water. Chemical symbol for water is H2O. I can make electrolysis of water. I can connect two cables into a cell, and this cell will make electrolysis of water, will divide water into two gases. Could we do the same with our salty water? Yes, I just put the battery inside, and in few minutes we will see bubbles of gas on one and another side. We do electrolysis. We make the decomposition of water into two gases. Well, in this fun equipment, I can do this with the solar cell. I illuminate the solar cell, and you will see that we get bubbles of gas on one and on another side, as the chemical formula of water is H2O. We get double amount of hydrogen than oxygen. On this side I get hydrogen, on this side I get oxygen. Well, what then? Well, then would be nice to make a battery which uses these two gases. And this is the battery using these two gases is here. I have accumulated the gases. I have just enough hydrogen and oxygen, and I can invert the machine. I can connect the engine to another cell like this. Let's look, it's here, and you see the fan starts going. I'm not illuminating it anymore. It goes with the two gases which were accumulated before. We call this fuel cell. This is not a very good name because, well, fuel we usually think petrol, but in this case the fuel is hydrogen and oxygen. At this point, the idea is following. I put a solar cell on the roof of my home. I charge the tank of hydrogen for the whole day. When it is full, I put this hydrogen into the tank of my car, and let's see, and it goes. It need not a solar cell. It goes with hydrogen which was accumulated inside. It goes. Well, I have a better car, the car you have seen before. I just made some electrolysis before. Now I have probably enough hydrogen. We need to connect the engine, and let's try. I connect the engine. Well, it obviously doesn't go because the hydrogen has disappeared in the meantime. I should charge it again. But this is a great idea. I call it water-driven car because I just put water inside. This is normal water. I make electrolysis. I accumulate these two gases. Then I can use these two gases to make the car going. This is the future of our transportation. A water-driven car. Thank you very much.